Hello and welcome to another NGen Math 7 lesson by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 1 Lesson 6 on ratios and rates. There may not be almost any more important topic in all of math than ratios and the associated idea of a rate, all right? Because this is all about having two quantities, whatever they are, and how much of one quantity you have compared to the other quantity. Now, you've been working with ratios and rates for at least 2 years now. So let's jump into it and do a review problem that gets at a lot of the fundamental ideas, especially with ratios. All right, let's move that out of the way. Let's take a look at a basic ratio review in exercise number 1. At a birthday party, the ratio of pizza slices to kids is 3:2, or 3:2. Letter A says fill in the table below to show the different possibilities of kids and slices of pizza. All right, so keep in mind when we see something like this, the ratio of pizza slices to kids is 3:2. That means that every time I have 3 pizza slices, I have 2 kids. Or maybe the better way to look at it is for every 2 kids, there are 3 slices of pizza. Now that doesn't mean at this party, I have 2 kids and 3 slices of pizza, right? That's the point in letter A. I could have 2 kids and 3 slices of pizza, or I could have 4 kids and 6 slices of pizza, right? Or I could have 6 kids and 9 slices of pizza, or I could have 8 kids and 12 slices of pizza, I could have 10 kids and 15 slices of pizza, and I could have 12 kids and 18 slices of pizza. Right? I could just kind of keep going on and on and on. And the idea of a ratio is that you can always multiply both quantities in the ratio to get an equivalent quantity. In other words, right here, to go from 2 to 8, I would multiply by 4. And to go from 3 to 12, I would multiply by 4. So I don't want you to just think about it as, oh, I'm just going to go 2, 4, 6, 8, 10, 12, go by 2s, right? 3, 6, 9, 12, 15, 18, go by 3s. I mean, yes. But at the same time, it's really about all taking this fundamental ratio, 2 to 3 or 3 to 2, and then multiplying it by the same quantity to get an equivalent ratio. Now, letter B says, if there are 8 kids at the party, how many slices of pizza are there? Circle in your table. Well, I think I pretty much pointed it out right here, right? If there are 8 kids, there are 12 slices. All right, but letter C, that's a little more challenging. Let's take a look. If there are 24 slices of pizza, how many kids are there? How did you find this without using the table? So what I'd like you to do is I'd like you to think about this a little bit. If I know that there are 24 slices of pizza, how many kids are there if there's this ratio of 3 slices of pizza for every 2 kids? Think about that for a moment. All right, well, we can do something very, very similar to this, right? Where we can say, right, I've got 2 kids, I've got 3 slices, right? So if I want to get up to 24 slices, I would have to multiply by 8. Likewise, if I multiply the 2 kids by 8, I get 16 kids. Now, if we had extended this table forever, well, not forever, but if we keep extending it a little bit farther, then we would have eventually seen 24 slices and 16 kids. Notice, by the way, right, when we had 12 slices, we had 8 kids. And if I double 12, I get 24. And if I double 8, I get 16. Getting equivalent ratios and working with ratios is all about multiplying and dividing both parts of the ratio by the same whole number. Let's take a look at letter D. Write the division problem 3 slices over 2 kids in its mixed number form and use appropriate per units. What does this rate tell you? All right, now you might say, wait, division problem? I thought this was just a fraction. Well, remember, every fraction is division, right? So what we're really doing is we're taking 3 slices of pizza and we're dividing by 2 kids. Now, what does that really give us? Well, here it says mixed numbers, right? So 3 halves is simply the mixed number 1 and 1/2. But keep in mind, there are units here, right? Specifically, slices per kid. You can always figure out the units of a ratio by looking at the top per the bottom, all right? So slices per kid, right? And what does it really tell you? Well, it tells you what's circled there. It tells you how much pizza each kid is getting. Each kid, understandably, is getting 1.5 slices. Because if I had 3 slices of pizza, and I wanted to split them up amongst 2 kids, well, each kid would get 1. Then you'd take that 3rd slice, cut it in half, and then each kid would get 1.5 slices of pizza. This is what's known as a unit rate. Whenever I take the numerator of a ratio and divide it by the denominator of the ratio, I get a unit rate. How much of the numerator I get per 1 unit of the denominator. 1.5 slices of pizza per 1 kid. All right, let's keep going and review more about ratios and rates. I gotta reach for that. Now, a lot of times people will use fractions, as we just saw, to represent ratios. And the reason why is that it's very, very nice to be able to use them to think about equivalent ratios. Let's take a look at this idea in exercise number 2. The ratio of left-handed students to right-handed students in a class is 2 to 7. There are 21 right-handed students in class. Letter A asks us to fill in the missing numerator to determine the number of left-handed students. All right, let's do it. Now what I've done is I've created a fraction, 2 left-handed students per 7 right-handed students. Well, if I really have 21 right-handed students, then I think to myself, well, I would multiply by 3 to go from here to here. So likewise, if I multiply by 3 here, I will get 6 left-handed students. In other words, 2 to 7, 2 left-handed to 7 right-handed, is the same as 6 left-handed to 21 right-handed. Let's take a look at letter B. In another room, there are 10 left-handed students. If the ratio continues to be 2 to 7, which would be remarkable, then how many right-handed students are there? Use an equivalent fraction to justify. All right, well, what I'd like you to do is pause the video for a moment and see if you can figure out how many right-handed students there are if there are 10 left-handed students. All right, now you may be wondering, well, which one should go in the numerator, which one should go in the denominator? And the answer is, it doesn't matter. It really doesn't. So actually, let's flip it up here just a little bit, right? We know the fundamental ratio is 7 right-handed to 2 left-handed. Just do a little abbreviation here. And we're told that we have 10 left-handed students. So to go from 2 to 10, we'd have to multiply by 5. If we do the same multiplication for the right-handed students, we would end up with 35 of them. All right? Again, beautifully done with these, let me just show that multiplication, with these equivalent fractions, right? It's all equal to 2/7 or 7/2, depending on how you look at it. Let's take a look at the final part of this problem, which is quite important. Letter C says, what fraction of the total students are left-handed in both A and B? Show how you arrived at your answers and write in simplest form. All right, well, let's take a look at this. Whenever we want to find a fraction that a part represents of the total, we simply put the part in the numerator, the total in the denominator, and then simplify if we can. So, in letter A, we have 6 left-handed students, 21 right-handed students, so we have 27 total students, right? And I want to figure out what fraction of them are left-handed, so that will be 6 divided by, actually let me put this down, 21 plus 6, just so we all know where it comes from, and that's 6/27. Now I can reduce that fraction by dividing both the numerator and the denominator by 3, and that's going to give me 2/9. So, in letter A, 2/9 of the students are left-handed. Let's take a look at in letter B. In letter B, remember, we had 10 left-handed students. We had 35 right-handers and 10 left-handers, so we had a total of 45 total students. I can reduce that by dividing both top and bottom by 5, and that's going to give me 2 ninths. Now, wait a second. That can't be a coincidence, right? And where's that 2 ninths really coming from? Well, if you think about it, right, for every 2 left-handed students, there are 7 right-handed students, and there are a total of 9 students. So whether we're talking about A or B, for every 9 total students, 2 of them are left-handed, right? So the fraction of left-handed students is 2 ninths. Okay, a very important idea when we're given a ratio of parts, and we want to kind of convert that to a ratio of a part to a whole. Let's keep going. Exercise number 7. Now let's talk about ratios and this very, very important idea of unit rates. A unit rate comes from dividing the numerator by the denominator in a ratio. And let's kind of look at that in exercise 3. We've got Beth is dividing up 18 gallons of water evenly between 8 buckets. So she's got these 8 buckets and 18 gallons of water. Letter A says write the ratio of gallons to buckets as a fraction in simplest form. So let's talk about this a little bit. Whenever we're writing a ratio as a fraction, right, when we have A to B, then that's A divided by B. So we're looking at the ratio of gallons to buckets. Gallons to buckets. So that's going to be 18 gallons to 8 buckets. Okay, it says simplest form. I can divide both of those by 2. So that means I'm going to have 9 gallons per 4 buckets. And by the way, this should really make a lot of sense, right? I mean, if I have 18 gallons in 8 buckets, right, then 4 of those buckets contain 9 gallons. Makes a lot of sense. Now letter B says convert the fraction in A to a decimal using division. Show your division. All right. Right? So now we're going to convert a fraction into a decimal, which we did not so long ago in the last lesson. Literally, we want to do just 9 divided by 4, right? So, literally, I want to do 9 divided by 4. So let's do that. 9 divided by 4, right? 4 goes into 9 2 times, leaves me with 8. I'm going to put a decimal point there, 0, 0, 0. You never know how many zeros we'll need, right? We do the subtraction. We get 10. All right, 10 divided by 4 is 2 again. That's going to leave me with 8. Subtract, I'll get 2, drop a 0, 20. And 4 goes into 25 times, and now I'm writing over the text, but that's okay. Do a subtraction, get 0. So there it is, 2.25, right? 9/4 and 2.25 are the same. That kind of makes sense. Think about it. 9/4 as a mixed number would be 2 1/4. 1/4 is the same as 0.25, so 2 1/4, 2.25. Get that decimal nice and big. It doesn't show up so well on the big screen. All right, 2.25, that doesn't look any better. All right, let's take a look at letter C. Using proper units, explain what the decimal answer in B represents in terms of the real world situation. That's what it says right there, terms of the real world situation. So what does that 2.25 give us? Pause the video now and write something down. All right. Well, the great thing is it's all about looking at the ratio itself, right? So what do we have? We have 2.25 gallons per bucket, or each bucket holds 2.25 gallons, right? A unit rate, gallons per bucket. Always this per this. Read it as the units of the numerator per 1 unit of the denominator. 1 bucket holds 2.25 gallons. How many ways can I hammer that home? All right, let's keep going. So, unit rates are amazingly important, right? And we can always find them by setting up a ratio in fraction form, then dividing the numerator by the denominator, which is what a fraction really is, the numerator divided by the denominator, and then have appropriate units. Let's see how that plays out in exercise number 4. In each of the following situations, set up a rate as a fraction showing units. Then use division to find the unit rate. Use proper per units in your final answer. All right, great, let's take a look. Letter A, Caroline runs 258 feet in 12 seconds. What is her speed, which is a rate, in feet per second? Now, we can always set up a ratio in 2 ways, right? It could be feet divided by seconds or seconds divided by feet. But specifically because they say feet per second, we know the feet must be in the numerator and the seconds must be in the denominator. So literally what we're looking for here is 258 feet per 12 seconds. Now I want to actually do a little bit of division here. Okay, so I'm going to take 258 and I'm going to divide it by 12. I don't know if this is going to be a decimal or not, but we're going to find out. Okay, 12 goes into 25 2 times. That gives me 24. Do a subtraction. I get 18. 12 goes into 18 1 time. 12, that leaves me with 6. So now I have to add a little decimal on. I'm going to drop that down into a 60. 12 goes into 60 5 times. 5 times 12 is 60. And when I subtract, 0. So I get 21.5 feet per second. All right. A unit rate based on a ratio by dividing the numerator by the denominator. Let's take a look at letter B and then have you work on it on your own. Letter B. Aisha drove 118 miles and used up 8 gallons of gasoline. How many miles per gallon does Aisha get in her car? All right. Now again, I'd like you to pause the video and work on this a little bit. Pay attention to which way the ratio should be set up, do the division, and find out that unit rate. Okay, let's do it. Again, how many miles per gallon? Miles per gallon means that we should have the miles divided by the gallons. So we're looking for 118 miles divided by 8 gallons. All right, and that, let's put it in this notation, 118 divided by 8. 8 goes into 11 1 time, 8, subtract 38. 8 goes into 38 4 times. That's going to be 32, subtract 6. Well, going to have a decimal now. Put 0.0 here. 60, 8 goes into 60 7 times. That's going to be 56, running into a logo. Subtract, get 40. 8 goes into 45 times. Thankfully, that leaves me with no remainder. 40, subtract, and I get 0. So we're going to get 14.75 miles per gallon. Every time we have a ratio, right? And it's something per something, the first thing goes in the numerator, the per becomes the division or fraction bar, and then the second part goes in the denominator. Do the numerator divided by the denominator, and you will get your unit rate. Every gallon of gas gets Aisha 14.7 miles. All right, let's keep going on this. One last problem. Exercise number 5. Michelle can walk up 21 flights of stairs in 7 minutes. At this rate, how many flights of stairs can she walk up in 10 minutes? Explain how you found your answer. All right, I'd like you to pause the video, think about this problem, and see if you can find out how many flights of stairs that Michelle can walk up in 10 minutes. All right, well, one way to approach this problem would be to use equivalent ratios, right? And we would do something like this. We might say 21 flights, 21 flights, I can't get this to right, divided by 7 minutes, right, equals, and then 10 minutes down here, and a question mark up here, right? The problem with trying to use an equivalent fraction in this case is it's kind of hard to think about what we have to multiply 7 by in order to get 10. It's just a little bit of a challenge, right? And this is where unit rates can really help us. Because for a second, forget about the 10 minutes, right? In fact, let me completely and utterly, well, I guess I got to delete all of it. Let me completely and utterly delete it all. At the end of the day, what we have is 21 flights per 7 minutes, which, of course, 21, I can't get this to right. That just looks like a sad face. 21 divided by 7 is equal to 3, right? Our unit rate here is 3 flights of stairs per minute. All right? So that is the unit rate that Michelle is climbing stairs. 3 flights of stairs per minute. So now, if we know that she's going to walk for 10 minutes, look at how great these units work out, times 10 minutes, it means she can get up 30 flights of stairs. Right? So that's where having a unit rate is great, because once we have a unit rate, something per 1 unit of whatever, then we can use that unit rate along with amount of time or something like that to figure out further answers. All right, let's wrap this up. Important ideas today, ratios and rates, so critical. The idea of a ratio, how much of one thing do we have per a certain amount of another thing, how to use equivalent fractions to think about equivalent ratios, and how to then take a ratio in a fraction form, do division on it to produce a unit rate, and how to think about the units of that unit rate. A lot of use of the word unit there. Anyway, we're going to see more of this in future lessons, obviously, so make sure you get a lot of good practice on the homework. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.